Second type of growth model is logistic growth model, which is shown when the food and space is limited. No population of any species in nature has unlimited resources to permit exponential growth. Means food and space is always limited. कोई भी पॉपुलेशन किसी भी स्पीशीज की ऐसी नहीं है जिसको कि अनलिमिटेड रिसोर्सेज मिले दैट कैन परमिट द एक्सपोनेंशियल ग्रोथ बिकॉज limited food and space leads to the competition between the individuals, and eventually the fittest individual will survive and reproduce. That is the Darwin's सर्वाइवल ऑफ फिटेस्ट रूल कि वो इंडिविजुअल जो कंपटीशन में सबसे ज़्यादा फिट होगा वही सर्वाइव करेगा और वही रिप्रोड्यूस करेगा. In nature, a given habitat has enough resources to support a maximum possible number, beyond which no further growth takes place. This limit is called nature's carrying capacity for that species in a given habitat. यानी नेचर में भी एक लिमिट है जहाँ तक वो एक पर्टिकुलर नंबर ऑफ इंडिविजुअल्स ही सपोर्ट कर सकती है, एंड दैट लिमिट इज कॉल्ड कैरिंग कैपेसिटी फॉर दैट स्पीशीज इन अ गिवन हैबिटेट. A population growing in a habitat with limited resources, it shows initially a lag phase. यानी अगर हम एक ग्राफ प्लॉट करें with time and the population density, logistic growth curve shows initially there is a lag phase. Lag phase जब population जो है population growth is slow, धीरे धीरे increase हो रही है. then a log phase when there is a very fast increase in the population size, then the growth becomes slow and ultimately it becomes stable. So this logistic growth is shown by S-shaped curve which is lag, log and stable. पहले धीरे धीरे increase है population rate, then it increases exponentially, then decreases again and it becomes stable. Here this is the graph when the resources are limited, and this K is showing the carrying capacity, that is the limit of the environment, limit of the nature, कि वो कितने मैक्सिमम नंबर ऑफ इंडिविजुअल्स को ही सपोर्ट कर सकती है. नाउ the population growing in a habitat with limited resources, it shows initially a lag phase which is followed by phases of acceleration and deceleration, yani increase and decrease, and then finally it becomes stable. This type of population growth is called Verlust-Pearl logistic growth, and it is given by the equation dn upon dt is equal to rn bracket k minus n upon k, where n represents the population density at a time t, r represents intrinsic rate of natural increase, and k represents the carrying capacity. Since resources for the growth for most animal population, they are finite and become limiting sooner or later. पहले चाहे resources बहुत होते हैं लेकिन एक टाइम आता है when the resources they become limited, then the logistic growth model is considered more realistic one. अगर हम दोनों को compare करें exponential growth और logistic growth को, तो logistic growth model is more realistic because ऐसा कभी नहीं होता है कि नेचर में फूड और स्पेस अनलिमिटेड हो. अगर बिगिनिंग में वो अनलिमिटेड होगा भी तो धीरे धीरे जैसे जैसे पॉपुलेशन बढ़ती जाती है द रिसोर्सेज दे बिकम लिमिटेड. सो दीज आर द टू ग्रोथ मॉडल्स, दैट इज द एक्सपोनेंशियल ग्रोथ मॉडल and the logistic growth model.